Hello and welcome to Naughty Daddy's videos entitled From Maths to Minecraft about computer science. In this video we're going to tie up what we've done so far and look at the 6 logical operations that we've covered and use more binary notation. So our operations are not, and, or, along with nor, NAND, and exclusive OR. And then we had our truth tables, A and not A. Now we used true and false, so we said false true becomes true false. Now in computers this is so useful for computer science because we remember computers think in binary. Computers can only handle 2 concepts, and those are 1 or 0, or a switch can be on or off. So this type of logic lends itself very beautifully to computer science. So what we have, if we say by definition false, oh dear, false is by definition 0, and true we are going to define to be 1. We can rewrite our truth table, replacing the F's for false with binary 0, and we can replace the trues with binary 1. Okay, let's do the same for and. So we have A, B, and A and B. And this time we're going to say false, false. A and B will therefore be false. False, true. A and B will be false. True, false. A and B will be false. And true, true. A and B will be true. And look what we're doing here. We're effectively counting in binary. 0, 1, 2, 3. So that means there's 4 combinations. Okay, let's look at OR. A, B, A, or B. And again we've got our 4 combinations, which is effectively just counting. So that's 0, 1, 2 is 1, 0, and 3 is 1, 1. And so the OR function, we'll remember, is defined as that. Okay, so NOR again is A, B, and not A or B. And we're knotting the whole OR function. Okay, so again we count. And here with nor, this time, A or B will be false, but the opposite of false is true. A or B in this case would be true, so the opposite, of course, is false. A or B is true, so the opposite is false. A or B is true, so the opposite is false. And then we do our NAND. A, B, A, and B is dotted. So again we count in binary. 0, 0, 0, 1, 1, 0, 1, 1. And then A and B is going to be false, but the not of that is true. A and B is false, but the not of that is true. A and B is false, but the not of that is true. A and B is true, but the not of that is false. And then lastly, the exclusive OR. A, B, and A exclusive OR B again we're counting in binary. 0, 0, 0, 1, 1, 0, 1, 1. A exclusive OR B and becomes 0, 1, 1, 0. Remember, it's either A or B, but not both. In the next video, we're going to have a look more closely at this exclusive OR function, because we've defined it as a compound function, but I've been treating it as if it's a primitive function, but it is a compound function. We can make this using the other ones. Alright, I'll see you in the next video.